Thank you. Good afternoon. It's a great pleasure to be back at GOTO Copenhagen. It's one of my favorite conferences, and it's been too long since I was here. So I will be talking to you about data the land DevOps forgot. I've been privileged to be part of the DevOps community, movement, revolution, whatever you like to call it. But lately I have stepped away from that and found myself in a different land. So introducing myself, yes, author, developer, architect. I've spent some time in operations, and a big part of my career has been going into different parts of the industry or related fields, and then coming back to the development space and sharing what I've learned. So I'm introducing myself and a little bit reintroducing myself, because for the last 2 years, I've also been a data guy. And I didn't come from that space. I mean, I'd always used databases and touched data, but I wasn't in the big data space. Now, I also need to introduce Nubank because it's not that well known outside of South America. So Nubank is a financial services institution. It was founded in Brazil about 11 years ago with the mission to fight against complexity and return power to the people. And the early market for Nubank was particularly the underserved and unbanked population, which was pretty significant. We tried to remove complexity, remove the hidden fees, the fine print, all of that sort of thing. And we've been rewarded in the market with pretty good penetration. We've got half of Brazilian adults as our customers, more than half of Mexicans, about half of Colombians. And overall, we've got about 100 million customers. Somewhat more, but 100 million makes a nice round number for a slide. Well, that's a lot of customers. They're using it for credit card, deposit account, some investments, lending, and so on. And so when you have a lot of customers making a lot of transactions, they're going to create a whole lot of data. And what I learned in the data world is that many of my assumptions and experiences from the transactional world were completely wrong. So the transactional world at Nubank, like a lot of companies, based on microservices. Individual teams, you build it, you run it, you do your own monitoring, you do your own recovery. Individual repositories moving at their own pace. And when we get to the analytic world, a lot of it is this batch ETL type of space. We're running nightly jobs. The nightly job takes more than one day, so any given day we have multiple nightly jobs overlapping each other. We're taking in about 50 petabytes of data from the operational systems. And we have more than 300,000 jobs running every night on lots of Spark clusters and lots of EC2 instances. We have a great relationship with Amazon. Now, in the operational world, when you're doing transactions, your work unit happens in microseconds or milliseconds if you're not that fast. You can deploy something in a few minutes. We've gotten pretty good at canary rollouts, zero downtime deployments. And the lag between when you make a change and when it's live in production should be on the order of minutes. If it gets much longer than that, we need to have a talk about DORA metrics and accelerate and CD pipelines and that sort of thing. But when we look at the analytics space, because we're running once a day, typically the work unit, your job, is going to run for multiple hours. We have some individual ETL jobs that do big modeling tasks that can take 14 hours to execute. Well, the deployment time also, you deploy, you commit your code in the day, and that night it gets deployed and run into a batch job. So if there's a problem in your new job, you find out tomorrow. Actually, if your job is not one of the first ones, it may be running more than 24 hours after it kicks off. So you could be in a position of committing some code Monday morning and finding out Thursday that it failed. Then you have to make a change, and you're not going to find out the results of that change until probably the following Monday. So we have days in this deployment lag. Now, Nubank's ETL is a little different than many other companies. Nubank has made some different technology choices along the way. All of our analytics run out of one repository. So we don't have the kind of fragmentation and multiple sources and different technologies that you see in a lot of companies. But I think you'll find that we're ending up converging on a similar set of solutions. So just a few more challenges to give you an idea of the scale of the problem we're dealing with. 7-ish million lines of Scala code. Some of it is framework code. Some of it is frameworks on frameworks. So we're actually generating a lot of these jobs. There are almost 2,000 contributors making 100 pull requests a day. And 2 years ago, it was taking 6 hours just to do a build and run tests. In fact, once the build was done, just starting the integration test and instantiating all the objects would take 20 minutes before it even began running test cases. So we have this big system, high consequence of making a bad change because you might break the nightly run, and that breaks the run for everybody. And you don't find out what's going on until a long time after you make the change. And so that means you have to create more and more and more tests to try and make sure nothing bad gets into the repo, which further increases the contribution time. So the result is pretty much exactly what you would expect. Very high cost of execution, frustrated users, sort of uncontrolled growth and dependencies because people would rather build new than change existing, because there's a risk of changing existing. So we ended up in this situation where we had this long lead time, a centralized operations team that was trying to make sure everything kept running and that all the ETL finished, even though they weren't the ones making the changes to the jobs, they were the ones who got woken up. Centralized operations. Unpredictable results, pretty poor stability. Low accountability because people would kind of fire and forget. They'd check in their code and then, somebody else had to fix it, so why should they worry about the quality of their code? And definitely accumulating technical debt. The cost trajectory was growing quadratically with the number of customers. That's obviously not sustainable in the long term. And a lot of frustration all around. So I looked at this as kind of the opposite of DevOps. It's what we had before DevOps in the application space. Some of you may remember the days of centralized operations and throw it over the wall coding. And it kind of sucked. I've lived on both sides of that wall. And it actually sucks for both parties on both sides of the wall. So it was clear that we needed a new paradigm that would radically increase ownership, increase accountability, and parallelize the problem of taking care of this tech debt and stabilizing operations so that things finished more often than they failed. We needed the new paradigm. And I want to pause for a moment and say, it sounds like I'm only talking about the downsides of this ETL system. But I need to point out that the previous ETL system took us from 350,000 customers to 100 million. That's some pretty impressive scaling. It's a testament to the design and thinking that went into it. That's a factor of 285. Not many designs I've made have held up to that kind of scaling, so I need to give some kudos to the people who created this thing. It took us from 1 product to a dozen products, from 1 country to 3 countries. Remarkable achievement. But it is possible for a design to be right at the time and in the context and still need to be changed later, and that's where we found ourselves. So in the new paradigm, we were looking for a way to enable independent, autonomous teams, moving at their own pace, supported by a self-service platform, and with very high discoverability and visibility. If you're thinking about this from a background of application development, you might be saying, well, this doesn't actually sound like a new paradigm at all. You're just talking about microservices and taking the microservices idea into the data world. And a little bit, yes, that's kind of true. But as we usually do in this industry, we had to invent a new name for the same thing in a different context. And the name in this case is data mesh. Now, the other thing that we usually do is we make up a name, we don't define it, and then we spend a decade arguing about what it means and whether this fits or doesn't fit. Microservices, for example. In this case, we're actually lucky in that the person who coined the term wrote down a definition of what it means. And that person in this case is Zhamak Dehghani. She wrote this article on Martin's blog and then later turned it into a book. And she laid down the 4 key principles that make data mesh a data mesh. Those are domain ownership, data as a product, a self-service platform, and federated governance. When we talk about domain ownership, what we're talking about is fences, boundaries. There's a saying that good fences make for good neighbors. And in our case, the problem that we were trying to solve was uncontrolled dependencies. When you have a monolithic code base, anybody can make a dependency from one component to another component, and that's what had happened. And it had happened over and over and over again. So we needed a way to establish some boundaries to allow people to change the things that they owned with more confidence that they weren't breaking everybody else downstream. So we're looking for data domains where we can say that there are some things you're keeping private, like what is the code for your transformation, what are the intermediate tables, if you have any, ephemerals, we often call them. Where is your storage? How is the storage accessed? But we're going to make public some things. Some of them existed before, some are new. So you're making public the schema and classification of personal data, financial data, Sarbanes-Oxley, that sort of thing. We're making public the lineage so that a consumer of your data product can look to see, when you say customer, where did you get that? Like, what is your definition of customer? Turns out that's not always an easy thing to define. So that lineage allows you to view and trace back, data product to data product. What were the columns? What were the contributions? Even as you keep the transformation itself private so that people don't excessively couple to those particular implementation details. You make public the idea of output ports. And the output port is like the format and modality by which you can get the data. So do you want it as a batch? Do you want it as an incremental table? Do you want it as a stream? Those are the output ports. And then, crucially, for this whole transformation to work, people have to have understanding and trust in the data products that they're consuming. Otherwise, they'll go upstream, get the same sources that you've been getting, and they'll duplicate your computations. And that is needless cost and waste. So the service level objective, when will the data be available, and what is the freshness of the data? So it's going to arrive by 8 a.m., and it will be yesterday's data, or it'll arrive by 5 p.m., and it's D+2, and so on. And then the quality rules. What kind of semantic assertions are you making about the attributes and entities in your data set? Well, this sounds really good. It sounds like a simple idea. I've explained it in 5 minutes, but it's not terribly easy to implement. For one thing, there are technical hurdles. We don't yet have the swagger of data. In the data world, people don't talk about APIs nearly as much as they talk about file formats. So you've got Parquet files, you've got iceberg tables on S3. That's sort of the meeting point for the different technologies. Trying to elevate to the idea of APIs as interfaces, we're working on it. We certainly need to make organizational change. And along with the organizational change, we needed to help data owners care about these data products. And actually, there's a little bit of a precursor step to that, which is who actually are the data owners? Data owner is not a role that we've had, and it's not a role that's often recognized in many companies. What we had were analysts who created jobs to answer questions. We had analytics engineers who were automating jobs and producing high quality, but nobody really thinking of the data as a product and applying that product thinking. So bringing product thinking to data was also a cultural change. We had to talk about, the data product is the thing that you're sharing. Not a data set, because that's just one day's instance, but the data product as a series of evolving information that needs to be self-describing, discoverable, understandable, and like every product, needs to be both viable and valuable. So these data product owners, part of our ownership rollout was helping the people understand this role, including the people who would be designated as data product owners, and their managers and the executives. Creating a new role inside a company is always a bit of a challenge because it's not understood at the beginning what to expect and what not to expect. So there's been a ton of communication, a ton of change management, but we've made a lot of progress. Speaking of progress, when you're making a big cultural change and a social change as well as a technical change, and data mesh is a socio-technical paradigm, not a tool, I have found it helpful to create a program around that culture change. This is a squad that owns the program. They're creating dashboards on how we're doing on rollout and implementation. They're tracking the adoption. They're managing the communications. They have shared OKRs with many of the larger business units that are adopting this move. And they're doing the executive reports to me and to the others. This is a temporary squad. There will come a time when we declare the rollout done, and they will move on to other things. The next part of what we need is a self-service platform. We had a thing we called a data platform, but if any of you have studied team topologies, you would probably recognize it more as a complex subsystem than a platform. We need a platform to help manage cognitive load. This is a complex world. You can imagine 300,000 jobs. Nobody knows the entirety of what it's doing. Understanding the data itself is the task. They shouldn't need to also spend a lot of time understanding the minutia of tuning Spark to run across large clusters. We do want to provide flexibility, and we want to provide these automated guardrails for two reasons. One, it should not be possible for one team to harm other teams. This allows them to each move with independence and confidence. But two, we also need to help the users understand when they're about to harm themselves. We had a very interesting situation not long ago where somebody removed about 98% of the execution time of a particular job by replacing an or in a query. This is not that unique. Everybody who works in data has some kind of a 99% story where a seemingly small optimization caused a massive change in execution time. So we want to help people understand what are they about to do to themselves. And to a certain extent, we want to allow them to spend money and time and resources where it's valuable to them, because we don't know the value of the data that they're working on. We're the platform provider. They know the value of the data and the business challenge that they're trying to solve. So we want to give users that power, but then provide them the visibility. Anytime you're developing a platform, one of the interesting questions that you need to think about is, are you building a platform for enablement or for enforcement? Very often you start with the intention to do the enablement, but then you get requirements from InfoSec and from compliance and from audit and from IT operations. And once you add all of those requirements in and you start applying some guardrails, you realize that it's actually harder to do things in the platform than outside the platform. This is when it's time to reel it back a bit and go in a different direction. Our platform needs to support the data owner, which means we need to provide some tooling that wasn't there before. And this has been part of the implementation and rollout. So just like in the transactional world, we need observability. In this case, it's less about the volume of requests flowing through a service and more like, what is the progress of the jobs that I'm running? I'm 12 hours into that 14-hour job. Is it going to finish in 14 hours, or is it stuck? When something breaks and we get an error, is it because the inputs are bad or the logic was bad? So you need some observability tooling to assist with all of that. You need plenty of automation. That's just part of any platform. You also need to provide guidance for optimization, because in the data world, that 99% thing happens all the time. And very often, it happens for reasons that people don't fully understand or can't actually predict. So it's useful to have the platform provide some information back on how to optimize the workload for that platform. Very simple example, we have a wizard that tells you when you need to adjust your number of Spark partitions. It's just a parameter that you change in your code, and then the next run will pick that up. But it's the kind of thing that normally we required some expertise on Spark and in the platform to do, and we've been able to externalize that and surface it and make it available for the data owners. We have those guardrails that I mentioned before. We also need to support the data consumers. And our mantra for the data consumers was to help them discover, trust, understand, and use the data. Now, in this case, we added some commercial tooling to our platform around a data catalog. A bunch of those on the market. There's some open source ones. I'm not making product recommendations. But a data catalog, previously, people had used code search in the monorepo to find the attributes that they were interested in. So command space, customer ID. Here's a table that happens to have customer ID on it. Where does it come from? I don't know. Was it meant to be public? I don't know. But I'm going to use it. And now that data owner has a new dependency on them that they didn't sign up for, or maybe don't even realize they've got. The other thing that happens without a catalog is you may have your data set that's rank 10 in a lineage, and so it normally finishes by midnight or 1 in the morning. But you make a new dependency, and now the thing you're depending on is much further in the lineage, and so your delivery time goes from midnight to 11 a.m. the next day, or 5 p.m. the next day, because you just went from rank 10 to rank 75 in a lineage. So the data catalog helps you understand the effects that you're about to have on your own computation. Anytime you create a platform for anything, this is true for developer platforms and data platforms, the platform itself creates a set of incentives. The things that are easy in the platform are going to get done more, and the things that are hard in the platform get done less. The things that the platform surfaces are visible, and what you make visible, you make manageable. Or the corollary, what's not visible is unmanageable. In our case, one of the things we needed to deal with was cost. And so we made our platform reveal its cost. We're also showing quality and performance, these optimization recommendations. At some point, we may implement transfer pricing, so there's an incentive for data owners to create high-quality data products. Right now, they're getting the cost attributed to them, but the value is sometimes derived by a different entity elsewhere in the company. Now, I've outlined a lot of change, and this change all had to happen against a backdrop of explosive growth in the company, multiple countries being entered, multiple products being launched, and a lot of transaction volume. Getting that kind of change to happen in a company under load is not particularly easy. So we have to talk a little bit about how do you get there? And of course, the answer is a little bit at a time. You do it incrementally. But there's a prerequisite even before that. In order to make incremental change, you have to have some space for change to begin with. And when you're working with a team that's doing production operations and they're under load all the time, they don't always have space to make the change. So we also found it necessary to make sure that we could create enough attention and enough white space for the change to happen. So we had to reduce the amount of firefighting that people were doing. The same team that was writing the platform was running the platform, and they were getting woken up at 3 in the morning to fix broken runs every day. We had to invest in some KTLO reduction, but as we did that, that also freed up more time that we could reinvest into further KTLO reduction, further firefighting reduction, or platform evolution. So we got enough support to be able to do a couple of rounds of this KTLO reduction, which freed up the equivalent of entire people. We also identified a fairly intricate multi-step program. I've simplified it here and schematized it, But the idea was that there's certain things you do that are prerequisites that unlock other things in your kind of tech tree. So domain ownership as a program and the rollout and the education of the data product owners was happening together with the firefighting reduction. Some changes to the contribution experience. So we managed to take it from 6 hours to get a change merged to about 3.5 minutes in the usual case. And the framework evolution that allowed us to create separation inside the monorepo, that's still underway, and will eventually allow us to create separate repos so that each of the data product owners, each of the data domains, is fully autonomous and fully operating on its own schedule. As we did these programs of rollouts and the evolution of the platform, we were also taking architecture increments that gradually built new capabilities that enabled the next round of new capabilities. So just getting some options around execution and storage, that unlocks some capabilities. Publishing the schema information to catalogs allowed us to go further with automatic classification. Automatic classification is using AI tools, actually they're glorified regexes, to find things like tax IDs and phone numbers in your transactional data. The quality assertions were also part of the firefighting. Now we can do quality assertions on a data set. When you're making a change on the pull request, a bot recommends that you do an ad hoc execution to run it in a non-production environment, get some results back, check whether those meet your quality assertions, and this lets you get same-day feedback about your change instead of Monday to Friday feedback. Of course, also lots of very deliberate change management. And in this case, I don't mean Git and GitHub change management, but the sort of organizational change management. A lot of explaining why and sort of communicating over and over again what is the urgency of the problem that we're trying to fix. Why is this something that we need to commit significant resources in the organization to? We needed to create some incentives for those data product owners to take on new responsibilities. We needed to make sure that there was room for us to refuse some priorities in order to do this evolution. And of course, we needed to create tracking and visibility. Oftentimes, a question about any kind of culture change will be, do you start grassroots upward? Do you start at the top and down? The answer, I think, is both. You need strong support from the top. You need buy-in from the bottom. And don't forget the middle layers of management as well. So top down, bottom up, middle out. You have to communicate with all of them. And remember that when you're sick of saying something, people are just starting to hear you. If you tell somebody that a thing is happening and they don't hear about it for 6 weeks, they're going to assume it's dead. While you may think it's going on, they think it's dead. Also, sometimes it helps to make things visceral. When we're talking about data and ETL, it's a little bit abstract. People outside of the tech industry don't really have a feel for it. But if you can provide a picture that communicates some of the challenges you're dealing with, you can make it visceral in a way that will gain support. And this may go down as one of the important pictures in Nubank history, because even the least technical person can look at that explosion and understand this is very complex. Something is not right. This is going to be hard to manage. This is going to be costly. In fact, when I put this picture on the slide, PowerPoint came up with alt text from an AI analysis that called it a colorful explosion of dots. It looks a little bit like that. It also looks a little bit like a mushroom cloud. So zoom in, zoom out, the color coding shows ownership, and you get an immediate feel for the complexity. So this is a good way of making it visceral. It's not just the rest of the company that you need to communicate with and build support. You also need to build support inside your own organization. And I think it's important to make sure that there's opportunity for everybody to come along on the journey. I've seen this anti-pattern in a lot of places where you create the new promised land where everything is going to be beautiful and clean. And then some people believe they're going to be stuck supporting the boat anchor that nobody likes anymore. And it's bad for their career, and it's bad for their lifestyle. So you have to provide a pathway where everybody can come along. Now, when I say don't create legacy versus promised land, it doesn't necessarily mean the systems. You can separate the systems, but provide a pathway for the people to come along. And like I mentioned about KTLO reduction and firefighting reduction to create the white space to allow change, lessening the burden on the implementers also allows them to get enthusiastic about making this change and to come along. And of course, Slack for change is crucially important. But I do have to point out that's a lowercase Slack, not the uppercase Slack. So summing it up, I think data mesh is a very promising paradigm. A lot of companies are arriving at it from different directions. We're coming from a place of very homogeneous, monolithic systems. Many of them are coming from a place of high fragmentation, multiple technologies, multiple stacks in different parts of the company. But we're all arriving at the idea that you need some kind of an interface to define what is the data that you're sharing, what are the assertions that you're making about it, what kind of promises are you providing. And then we decentralize the production and consumption. And there's a lot of very interesting machinery around that, and tons and tons of vendors who are putting data mesh on everything they've ever sold. Some of them, it's more real than others. As you're doing this decentralization, there is a part that you want to keep centralized or re-centralized. And that's the rules about the platform and about governance on the platform. When you're talking about data, a lot of it's very sensitive. Some people have called data the new oil, but it's actually more like the new uranium. Very powerful when it's used well, very dangerous if it leaks out. We want to make sure that we don't have data leaking out, and so we provide these governance rules. We can federate the governance execution, but the governance rules need to be centralized. So this is an evolving journey. We're about 2 years in, made great strides. I hope to come back and report how it goes a little further along. So far, I can say the progress is very promising. Multiple people have talked about this as a game changer. And hopefully we'll be done in 1 more year. So with that, I thank you for your time and attention.